Now we're going to look at linear regression. We will be using regression analysis throughout this course, so you need to get used to the calculator steps because that's what we do to find our equations. Well, I'm getting ahead of myself. Regression analysis is a process for finding a function, an equation, that provides a useful model for a set of data points. We will use our calculator to produce a line that is the best fit for a given data set. And the calculator does it on its own. So here are the steps to find, it's called a least squares line or linear equation when given at least 2 points. Let me get my calculator up here. Mine's already on, so you turn it on, and here's your stat key right here. And you press stat. First thing we need to do is press 5, and we only should have to do this once. I'll tell you when you'll have to do it again, but if you don't do what I tell you not to do, then you'll be okay. So press 5 and then hit enter, and it should be done. So that should be the only time that we have to worry about this. Now the next part, it says use your cursor keys to get to the column headings. Well, I have to go and press stat and then hit enter. So let's go do that. I can't make my calculator small. So press stat. When you press stat, we won't be using 2, 3, 4. We shouldn't have to use 5 anymore. So you should know what edit means. Edit means I'm going to go and change some values. So it said in step 5 to press stat and then hit enter. So let's go edit. Now some of you might have data values and some of you might not. In step 7 it says use your cursor keys to get to the column headings. Well, since I've got my cursor right now is here, let me go up and notice I'm on my column heading. So if you'll hit clear and then hit enter, it clears out that column. Let me go over to column 2. I'm going to go right, go up, press clear, and then hit enter. Now what I need you not to do when you get to the column heading is press delete. If you press delete, it deletes the column. So I don't need that. Don't press delete. So now I've got to go back and do steps 2, 3, and 4 again. So stat 5, enter, and let's go see if my column's back. Okay, make a note. Do not press delete. Okay, so let me get back here. So use your cursor keys to get to the column headings. Once they're pressed clear and then enter. Move to all column headings that contain data values and repeat this process, which should be column 1 and column 2. This will clear any old data values so that you can input new ones. Cursor back until you are in the L1 column, and this is where all your X values go. You put in the number, press enter after each one. After all the X values are in the first column, press your right cursor key, so now you can put in all the corresponding Y values. Then we go to stat. Now steps 7 and 8, we'll do this regardless of what type of equation we're going to find. But now step 9 we'll do hit stat. Step 10 where we get to the calc menu. Now what can change is step 11 depending on what type of equation, regression equation, you're asked to find. So you need to read. Because right now since we're doing linear equations, we'll be doing linear regression. You hit enter and your display should look similar to this right here. We'll go do a problem here in just a second. Now if you do not have the R squared and the R, these are the steps that you have to complete to get those. And I will go through that here in just a second. Now the R that's referred to right here is called the correlation coefficient. The values of R satisfy where R is between and including -1 and 1. Where a line fits the data better if R is near -1 or 1. Actually, if you come up with an R value of 1 or -1, it's a perfect fit. A value for R near 0 indicates a poor fit, and don't use it to try and find other values. We will use our regression equation to approximate points that are not in the data set. So interpolation is the process when we use our regression equation to approximate points inside the given set, and extrapolation is the process when we use our regression equation to approximate points outside the given data set. So let me go to the next page and we'll look at an example. The following table gives data from the National Center for Education Statistics, U.S. Department of Education, on tuition at four-year private colleges for the period 1995 to 2000. They want us, some of the problems ask you to plot the data and check to see if the points seem to lie in a straight line. Now it does say the word seem. It will not be perfect. So what I did here, move it up a little bit, is I went and made me a table. And if you'll notice, I started at 11,000 and I went up to 15,000. These are my Y values, and my year I put on my x-axis. And then I tried plotting the points as best as I could. So if you'll notice, it looks pretty good. That's sort of a fairly nice straight line. I see as years progress, the tuition increases. So the points aren't going back and forth. They seem to keep going up. So yeah, it does seem to be in a straight line. Now it says determine the linear equation corresponding to this data rounded to the third decimal place. Alright, let me get my calculator back. So to get here, let me clear that off. Press Stat and Edit. And I'm going to put in all my years first. So 1995, 1996, 1997, 1998. I'm going to mess up on this next one. Now I go over and put in the corresponding Y values. And I need to check. Your calculator will give you an equation regardless of what points you put in, but there's only one equation that's going to go with this data set. So please make sure, because I do have some people who transpose numbers. 129213, and I see that I've messed up right here, so let me go back over and just put your cursor over the issue and then type in the correct value. So you don't have to put in all the data. So all my data sets in. Okay? So now we have to go to Stat. Once you have all your data in, we will never use Test, never ever. But let's go over to Calc, because we want the calculator to calculate an equation for us. We won't do 1, 2, or 3. You might more than likely use those in statistics if you have to take that class. But here's regression. Do you see the REG? Here's linear regression, quadratic, cubic, quartic, whole bunch. We'll be using some of these, but right now I want 4. So if you'll press 4 and then press enter. Now if you'll notice, my R and R squared's not there. So let me move back up here. Get my calculator back up. So it sort of looks like this, but I do not have these. So here I go. If it does not appear, then you need to do the following procedure once. Do second, 0 for catalog. You can get to where you need to go in one of two ways. Since this is in alpha mode, if you'll go hit this key right here where D is, because I need diagnostic on, you'll get there a little bit quicker. Or you can just cursor forever and eventually you'll get there. So this thing needs to be right at diagnostic on. Hit enter and hit enter one more time. Now let's see if I can go back and get that. I want to go over to Calc, number 4 for linear, and let's see if I've got my r squared and r. So there they are. And notice my r, 0.99, very, very close to 1. So a pretty good fit. So let me go back down. Let's see what the directions are. Determine the linear equation corresponding to this data rounded to the third decimal place. So let me get my... So now every one of your calculators, every one of the 83s and 84s, you have the equation built in here. You just have to put the number in for it. Don't write down this screen. So my y would be 630.457x minus 1246269.476. So let's see if that's what I put here. What is the correlation coefficient, and is the equation you found in Part B a good fit? Remember, it was 0.994 something. And yes, it is a good fit. Let me get it back up and see if I type my numbers in. 1246269. Okay. Now here, estimate what the tuition would be in 2005 and 2010. Once you find your equation, you're going to use it. So now I need to know what y's and x's. Remember, the x was the year, the y is the tuition. So they're giving me the year, so I need to substitute that in. So let me store 2005 in for x. Type in that equation, 630.457x minus 1246269.476. And let's see what the tuition. Around 17,800. So that's what the tuition should be around in 2005. Whoops, wrong one. I wish my calculator would stay up, but nope. So there's that one. So let's try 2010. 2010. Storing for x. And second enter. Second enter. So around 20,949. Wow. So that's how you use your calculator. Now, since these were after our data values, this would be called extrapolation. We're trying to, figure out what it might be in the future. We might be close if the trend stays consistent. I've got another example. Gasoline consumption of a car depends upon its speed. To determine the effect of speed on fuel consumption, the Federal Highway Administration tested cars of various weights at various speeds. One car weighing 3,980 pounds had the following results. So I'd like you to pause me and see if you can go find the equation. Okay? I'm going to go ahead and find it, but you got to pause me. I need to use edit. Let me go up to column heading, hit clear, enter. Over, column heading, clear, enter. Go back. My x values are going to be speed. My y values gas consumption. So I've got 30, 40, 50, 60, 70, 33.1, 30.3, 28.0, 26.5, 24.8. And double check your values, 30, 40, 50, 60, 70, 30.1, 30.3, 28, 26.5, 24.8. And we got to go find the linear equation, so stat, over to calc, number 4, enter. So it looks like because this is a negative, I've got a negative slope. So the faster you go, the worse your miles per gallon. So let me delete this and see if that's what I wrote down. Okay. Use this equation to estimate the mileage per gallon, the MPG. So they're asking me to find the Y of this car at 55 miles per hour. So let me store in 55. And then type in negative 2.0 whoops, 0.204x plus 38.74. So is that it? Okay. So it looks like it'll be around 27.5 miles per gallon. 27.52 miles per gallon. But that's how we use our calculator to find equations. And yes, you'll be doing this all the way through this class. Talk to you later. Bye-bye.